Hello, Mr. Crow here with the first of your reverse labs. So, you're doing reverse labs because you can't come into the laboratory as I am here and do real labs. What you have to do is a bunch of other things. One of those things is write down the method. Now that's not as easy as it sounds. Normally, in a chemistry experiment, maybe you might get a sheet of instructions and you follow those instructions brilliantly and you never make any mistakes because you're really, really careful chemistry students, and then you come up with some data and then you do something to that. This time, I'm going to do stuff. I'll talk you through what I'm doing, but you have to understand it enough to write a coherent method. And that method has to be so clear that anybody coming into this lab will be able to do what I have done and get the same results. So what we're going to do today is generate some data. The data today isn't going to be particularly numeric. It's going to be about pH. So pH, you'll be aware, it's a measure of how acid or how basic something is. And you probably did something about it back in middle school or even elementary school. But this is going to add something to it. There is going to be a quantitative component, which means you'll have to deal with some numbers, but there'll also be a qualitative component because how we're actually going to show that our jiggling about with an independent variable has some effect is by using an indicator. And the indicator is this. It's red cabbage. So I've chopped up the rest of this red cabbage, stuck it in here, and it's bubbling away merrily on this hot plate and making my hand rather warm. So that is a collection of organic compounds, that red cabbage. And that collection of organic compounds has some that are pigments. And pigments basically reflect light at certain wavelengths. And when environmental conditions, such as pH, change, then they reflect light in a different manner. And therefore, we're going to see a difference in the colour of that indicator that is in the cabbage. Now, there's more than one substance that changes colour, so we're going to get more than two different colours. You're used to litmus, maybe, that turns red or pink in an acid and blue or purplish in a base. And at neutral, around about the pH of 7, it sort of wavers about and doesn't know what it's doing. What we've got here is quite a number of indicator compounds which change colour, structure and therefore colour at different pHs, and so this whole thing gives a decent sort of range of pH colours. But what I'm going to do first is serial dilution. You know what dilution is? You have something, like say you go to Turkey and get some tea and it's massively strong and the tannins burn your little mouth because it's so delicate. And so you put a bit more hot water in it. You dilute the tannins, you dilute the substances that are having that effect, and therefore the effect is lessened. And the effects that we're going to talk about are those of acids and alkalis. Oh, here's my alkali. It's sodium hydroxide, NaOH. And it's an organic compound. It's going to split up into two ions when we stick it into water, which it is already. And here is HCl. And HCl is hydrochloric acid, and it does what acids do and gives off an H plus ion when it's placed into water, as I've done here, and leaves whatever else is left, a negative ion, in this case Cl minus. All right, so I'm now going to start with the idea of serial dilution, or this video's gone on way too long, so I'm going to do it on another video. Bye!